Today I am explaining about the rolling motion. Rolling motion is one of the type of the motions. For example, circular motion, oscillatory motion, translatory motion, and vibratory motion, etc. So, but rolling motion is completely different. How it is different means when the vehicle is moving, all vehicles are now moving because of the rolling motion of the tires. Okay, so that is very complicated. Why? Because rolling motion is a combination of pure rotational plus pure translatory motion. That's why rolling motion can be explained, that is pure rolling motion. Pure rolling motion is the combination of pure rotational plus pure translator. So in case of this rolling motion, what is first we will understand what is pure rotatory motion. Let a body, that body might be a disc or sphere or whatever it may be, okay, which is rolling on a horizontal surface. In case of pure rotation, every particle, pure rotation means this body will be rotating with angular velocity omega and its radius is let r. So that every particle will have the tangential velocity because of this omega, r omega acting. So here also r omega acting, here also r omega acting, here also r omega acting. So this tangential velocity will be acting along the tangent at every point of the rolling body in case of pure rotation. But the direction of the omega is perpendicular to the plane, okay, and according to the rotation, suppose this is clockwise means into the plane, anti-clockwise means out of the plane, along the axis omega will be acting, right? Now what about the pure translatory motion? In case of pure translatory motion, again considering the same particles A, B, C, D. Okay, the same particles or every particle on this body will have the same translatory velocity. Means any particle you consider, or center also. Okay, so every particle, because pure translatory motion means every particle will have the pure translatory, that let this body will be moving with a uniform motion, means V is constant. So here also, okay, what we called it the here, this is Vt. Vt means here also translation, but because of the rotational, every point will have the translatory velocity is Vt is equal to r omega, but there only purely translatory velocity, that is V. By combining pure rotatory and pure translatory motion, again when we are when we are observing the motion of same particles A, B, C, D, by combining that effect here, V, r omega and V also acting in the same direction here at the top point, but at the bottom point r omega acting left side and V continues in the forward direction. Similarly here V in this direction, r omega in this direction, resultant velocity is in this direction. Similarly here V in this direction, r omega in this direction, resultant velocity is in this direction. And let at any arbitrary point O, at this point let this point will be at a distance r from the center, then which is again perpendicularly r omega, means translational velocity because of the omega in this direction acting because of the r omega, okay, but translatory velocity will be again same. So this is the scenario regarding the pure rolling motion, about the combination of the velocities, how the velocities are combined they are affecting in rolling motion. Now in the second stage of this lesson, what are the conditions for pure rolling? Okay, Pure body will be rolling in two types only, pure rolling and without pure rolling. Without pure rolling means body will be slips, whether it is forward or backward. Okay, that all we will discuss in this lesson now. But now we are going to know about only pure rolling. Conditions for pure rolling. Conditions for pure rolling means here how can we understand what are the conditions means. Let's suppose same a body will be rolling on a horizontal surface, right? But here we assumed a point P, a particle P here. This particle will be instantaneously at rest with respect to the surface. This surface is here at rest and this particle also at rest means there is no relative motion between the particle and the surface. In this situation, right, net force acting on the particle is 0. But what are the force here? If it is a rough surface, there is a frictional force acting. That frictional force worked, okay, here 0. For pure rolling motion, there is no frictional force acting at this point. Why? Because net force 0 means ma is equal to 0 means a means change in velocity by time also 0 means change in velocity is 0. But here what is the change in velocity? V forward direction or omega backward direction acting when body is rolling in the clockwise direction with radius r. Then according to this, what is the change in velocity? V difference of r omega which is equal to 0. Therefore, V is equal to r omega. This is the conditions for pure rolling. Okay. Here static friction is self-adjustable. Whatever it may be, it is omega is greater or okay, V are greater or whatever it may be. V is acting. This is the velocity of center of mass, and every particle also will have the same forward velocity transverse, that is tangential velocity. So that at this we are considering the point P. What is the motion of the point P, right? So as the relative motion with respect to the surface is 0, then obviously we will coming to conclusion V is equal to r omega condition. According to when this condition is applied everywhere in the problem, suppose they are giving pure rolling means we are applying this and solving the problems. Okay. Now we'll do one problem. Okay. When this body, that is bottom surface or top surface will be moving, or bottom surface is moving, what happens? Same problem. Okay. Example. That is also simply suppose instead of fixed surface, this surface is moving with a velocity Vs. Okay. Now this particle velocity is Vp. And velocity of Vp, nothing but this is V, this is V is equal to r omega. Now, what is the velocity of P with respect to Vs? That is Vs minus Vp, right? Vs minus Vp is equal to 0. Therefore, Vs is equal to Vp. If Vs is equal to Vp also, there is no relative motion between this particle and this body. At that situation also, we will coming under body will be comes under pure rolling motion. Okay, that means velocity of the particle we know. What is the velocity of the particle? V minus r omega difference, which is equal to Vs. Okay, so in this case, suppose Vs is 0. Vs is 0. Relative motion means 0 means if Vs is equal to 0, okay, then relative it is under comes under pure rolling motion. If Vs is not equal to 0, it is slipping forward or backward. Okay, this regarding this we will do one problem, then we will get some clarity. Let's suppose a body will be rolling on a horizontal surface, or let's suppose this is a bottom plank which is moving with velocity 2v, and there is a top plank on a top of the rolling body which is okay, this plank velocity is let v, right? They are asking what is the center of velocity of center of mass of this rolling body. Let radius will be r. Okay, but because of this relative velocities of these two planks, here the velocity, whether it is acting forward or backward, we cannot estimate now. That's why let it is moving forward now, and forward motion is related. Okay, we will consider it as a positive direction. So according to that, we will apply the V is equal to U plus AT, or otherwise, like in the previous case, in case of pure rolling motion, what is the velocity of A? VA nothing but V. V is equal to, what is the velocity here acting? R omega also. So that is a transversal velocity or omega, sorry, VCM plus R omega. And again in the bottom surface, when we are considering the bottom surface, R omega acting backward direction and forward direction VCM will be acting. But here also, which is greater than the, which is more velocity when compared to VCM, R omega is more. Because of that, 2 will be acting backward. So that 2V resultant velocity is equal to here R omega minus VCM. So after solution this VCM cancels, R omega plus R omega, 2R omega, 3V is equal to, therefore V is equal to, V nothing but here, V is equal to, or R omega find out, R omega is equal to 3V by 2. But in the question they are asking what is VCM. So now substitute this R omega in either of the equations, then we will find V is equal to VCM plus what is R omega, 3V by 2. 3V by 2. Therefore, VCM is equal to V minus 3V by 2 means minus V by 2. That means here initially what we assumed, that is not correct, which will be acting backward. So this way we will understand whether the bottom surface is in motion, how the velocity of center of mass will be affected and its direction is changes. We will understand in this example. Similarly, we understand the velocities, okay, in case of pure rolling motion. Similarly, what about the accelerations? What about the accelerations of the rolling body? In case of rolling motion, we know if the net force is acting here, then only every particle will be having the accelerated. So, what type of accelerations will be acting? Only accelerations we will discuss here. We are not discussing about the forces. When body will be rolling, okay, what are the acceleration acting? This is the center radius and which will be moving with angular velocity omega. And because of the omega changes here, the body will get angular acceleration. That's why here not uniform angular velocity. Might be it is here uniform angular acceleration. That's why because of change in angular velocity, there is a, let this body will be rolling with uniform angular acceleration. Therefore, tangential acceleration is R alpha acting tangentially at this point A. And towards the center, centripetal acceleration or radial acceleration is omega square R acting downwards. And again, when this body is rotating in this direction, angular acceleration is acting in this direction. And again, as the transversal, tangential, this is a tangential acceleration, and again translational acceleration means this body center of mass will have some translational acceleration, ACM. Simply we say it as A. So that's why here there are 3 accelerations at this point. Let it be transversal acceleration, tangential acceleration, and radial acceleration. Three types of acceleration at a same point will be acting. Besides this, angular acceleration is angular acceleration is a let it be common for the rolling body, which is moving with a constant angular acceleration motion. So similarly, at another point you see here also transversal acceleration acting, and tangential acceleration is at is equal to r alpha, and again at this point radial acceleration is omega square acting towards the center. So like this every point. Here also tangential means r alpha, here a, here towards the center omega square r. That's why in case of pure rolling motion, even though body moving with a pure rolling motion, right, because of the centripetal acceleration the body will be rolling forward. So that's why we are neglecting the forces, simply how the rolling body will be affected with the accelerations when omega is changing. That is very important. That's why when omega is changing, how the accelerations are affected by the each particle on the rolling body. Now, on the same concept, we will understand about the velocity and time. After what time initially the body will be not pure rolling motion, means this is not pure rolling motion. How the body will be comes to rolling motion to pure rolling motion, how much after which velocity or which time they are asking. This type of question also very frequently asking in the examinations. How to face this type of questions? Let us see one more example here, right? Let a body will be rolling on a horizontal surface, and let the top point A will be moving. Its initial angular velocity is omega naught. Therefore, what is the angular velocity here? Let V naught by 2r. That means initial transversal velocity is V naught. So, and the radius of this body is r. And after which time or after which velocity, means after some time the velocity changes from v2 changes to v after some time t. After which velocity the body will get the pure rolling motion. That is the concept here. Very simply we will get the answer from this some exercise. What are the exercises here we are going to use to solve this type of questions? Means like in the previous case, V is equal to, we are using the kinematic equations, linear kinematic equations. V is equal to U plus AT. This is linear kinematic equations. So V is final velocity we want, initial velocity is let V naught given. A means acceleration. So acceleration here negative. Why negative? Means here frictional force. This is not a smooth surface, rough surface. Because of the rough surface here, body is not in pure rolling motion. Therefore, as the V naught is equal to 2 omega naught r. That's why 2 omega naught r. That's why here body slips forward. Therefore, frictional force acting backward. So that we know the frictional force Fk is equal to mu mg. Right? Only force acting here along the horizontal direction. That's why which is equal to m into a. Therefore, acceleration is equal to mu g, which is negative. Why? Because frictional force always reduces the velocity of this rolling body. So that's why we are getting here in place of a minus mu g into t. This is equation 1. As far as we consider the rotatory motion, rotatory kinetic equations. This is linear kinetic equation. What are the rotatory kinetic equation? Omega is equal to omega naught plus alpha t. So similarly, how we calculated the linear acceleration from the linear motion. Similarly, from rotatory motion, we will obtain the angular acceleration from the rotatory equation. What are the rotatory equation? What are the force acting on this body? Frictional force into perpendicular distance from the axis of rotation is r, which will provide the necessary torque to roll it, which is equal to I alpha. Therefore, alpha is equal to F means mu mg into r divided by I means m k square. Cancel. Therefore, alpha we calculated as mu g r by or k square will be a moment of inertia will be different for different bodies. Let this is a, if we consider this body is a solid sphere or disc or whatever may be, therefore moment of inertia of a solid sphere is equal to 2/5 mr square. So in place of moment of inertia, if we are substituting 2/5 mr square, r cancel, also cancel, therefore we will get mu g 5/2 mu g by what are the remaining here r. This is the alpha value from the rotatory motion, rotatory kinematic equations and the rotatory forces. From the linear forces, we calculated the linear acceleration from the linear kinetic equations, right? This angular acceleration is substitute here. Omega is equal to omega naught plus, here alpha is plus here, not minus. Why? Because it is rotating in a along the direction of the angular velocity. Therefore, 5/2 mu g by r into t. But here there are simply we will change here. Omega is equal to v by r. V we have to find out. Omega naught. What is omega naught? V naught by 2r. V naught by 2r plus 5/2 mu g t by r. R cancel, and whole this equation is multiply with 2, then we will get 2v is equal to 2 cancel v naught plus 2 cancels 5 mu g t. This is equation 2. By solving 1 and 2 equations, here 2v is equal to, and again this equation is multiplied with 5. Therefore, multiply with 5. 5 means 5v is equal to 5 v naught. 5 means here we are multiplied with 2 now already, right? 2v. Here this is fine. This equation is multiplied with 5. Therefore, we will get 5v is equal to 5v naught minus 5 mu g t. Why? Because to eliminate this 5 gt, 5 mu gt, here also we will get the 5 mu gt, then we will get the v value. But what is the second equation? 2v is equal to v naught plus 5 mu g t. After simplifying, we will get 7v is equal to 6v naught, implies v is equal to 6/7 v naught. Right? This is the if you know the v, substituting v value and a value in the first equation, or first equation will get t, or from this one find the omega and again alpha, and again here also we will get the t value. So this way we will get the after which time or after which velocity the body will get from in non-pure rolling motion into rolling motion. Why? Because this velocity will be reduced here 6/7 times the initial velocity. So obviously its velocity goes on reduces at a certain instant of the time, then this body will be get pure rolling motion. So this is the this type of questions are also asking in case of rolling motion, velocity and time. And regarding the acceleration, right? So sometimes acceleration also asking with the effect of the friction. So that's why, what is the effect of the friction? What is the effect of friction? Okay. So how the friction will be acting in case of rolling body? Let here initially let the surface is smooth. If the surface is smooth means, what is the velocity of this particle? 0. Means here there is no frictional force. No force means velocity is 0 obviously. Okay. Therefore, if Vp is equal to 0 means if it is rotating with angular velocity omega, and will have the tangential velocity or transversal velocity v. Therefore, r omega in this direction, v in this direction. Obviously, v is equal to r omega. In the case 2, same body will be okay. Now this surface is rough. So what is the direction of the friction? Mean here, if the surface is friction and which is rolling rotating in this direction, okay, let the radius of the body is r. If it is a rough surface, frictional force acting. But here, according to, if v is greater than r omega, frictional force is acting backward. Initially, right, static friction. When it is slips forward, frictional force acting backward. When it slips again, kinetic friction will be acts. So, if r omega is greater than v, what happens? Body slips backward, friction acting forward. So this is the scenario regarding the friction acting in case of rough surface and its directions according to the velocities changes. So it is fine up to this some basics points we know, but sometimes they are asking acceleration of the body, rolling body, right? So how can we find the acceleration of the rolling body in case of it is not a pure rolling motion? Why? Because here some external force F acting here, and this is the rough surface. Rough surface means the body will be okay on contact surface. There is a frictional force acting. Okay, as the force acting forward direction, because of this torque, the body will be rolling in this direction. Therefore, angular velocity will be acting in this direction. In addition to this, let tangential velocity will be acting forward direction. Obviously, the body shifts forward, therefore friction acting backward. That's why this friction also producing the torque in the same direction, clockwise only. As the torque is in the same direction, what is the net torque here? Force into perpendicular distance, or plus frictional force into perpendicular distance, which is equal to I alpha. I means mk square. Okay, initially you write it as I into alpha. Therefore, F plus Fs is equal to I means mk square, or you initially I only, and alpha means A by R into this R coming down, R square. This is equation 1. This is comes under from the rotatory motion. As we considering the translatory motion, right? Because all rolling bodies will have the combination of rotational and translational. Every time that two motions considering, we are framing the equations and solving those equations, we will get the required parameters. While considering the translatory motion, what is the net force acting on this rolling body? F minus Fs, which is equal to mass times acceleration. Why? Because here initially we consider this body will be slipping forward as force is acting Okay, forward frictional force acting, backward net force is F minus Fs, obviously. Therefore, this is equation 2. From 1 and 2 again, F minus Fs is equal to Ma. Combining, we will get 2F is equal to, take I or A constant, we will get I plus, take Ma constant here, only Ia only there, na? So that's why if A constant here, M plus I by R square. So from this one we will separate the acceleration. So therefore A is equal to 2F by M plus I by R square. Suppose if you want solid sphere, substitute moment of inertia 2/5 mr square, then we will get 2/5 means 5 coming top, 10F by 5m plus this 2m, 2/5. I means mr square. R square cancel. That's why here we will get 7m. So in this way, whether they are asking solid sphere or disc or hollow, whatever it may be, substitute the moment of inertia and get the acceleration of the body. This is also one of the model in this rolling motion. Okay, we will see many problems across this concept also. Next, we will go through the motion of the body on inclined plane. Okay, motion of the body on inclined plane. Rolling motion on inclined plane. Rolling motion on inclined plane. So regarding the, before going to that, if you want to know kinetic energy, okay, or translatory kinetic energy, rotatory kinetic energy also, once in few minutes we will discuss it. When body is rolling on a horizontal surface, right, its mass is m, radius is r, right? So what are the total translatory kinetic energy of mass of the body into, let this body moves with a translator velocity v of m v square. Since as this body, when this body is rotating with angular velocity omega, right, in addition to the, means rolling, when the body is in rolling, that's why kinetic energy in rolling motion, kinetic energy of rolling body. Kinetic energy of rolling body means total kinetic energy is equal to translator kinetic energy plus rotational kinetic energy. What is rotational kinetic energy? Of I omega square. Therefore, Ke rotational is equal to half m v square plus half m k square, radius of gyration square, into v square by r square. So taking half m v square common, we will get 1 plus k square by r square. This is the total kinetic energy of rotational body. But what is the translational kinetic energy of the body? Only half m v square. They are asking the questions regarding this also. Ratio of, find the ratio of translational kinetic energy to rotational kinetic energy of different geometry of the bodies. So using this formula we will get the answers. So now rolling motion on inclined surface. Rolling motion on inclined surface. Okay, this is the last topic. So rolling motion on inclined surface. So let a inclined surface is h and inclination length is let L and angle of inclination is theta. Let a body of radius r is rolling on a inclined surface, right? Then As we know, its mass is m. Okay, its radius is r, and due to gravitational force mg acting downwards and normal to the surface. Okay, this is normal force acting upwards, and which is balanced by, if this is theta, mg has two components, mg cos theta perpendicular to the surface, parallel to the surface mg sin theta, right? Here also, due to gravitational force, the body will be rolling down. Okay, the body will be rolling down, but as the body will be rolling forward, and because of this, okay, gravitational force, obviously we will understood that the body will be rolling down. Okay, then as the body will be rolling down, then there is a frictional force acting backward, okay, which will opposes the rotation of the body, right? Because of this component, body will be rotating. Okay, this is not changing. Why? Because this is fixed, but which will be changing, this omega will be changing by the frictional force, so that to decrease the angular velocity of this body, frictional force acting upward direction. Now, equating these forces or considering the rotationary motion and translatory motion here also. First, we will consider the translatory motion. What are the translatory motion will be acting on this rolling body? Mg sin theta acting, mg sin theta acting forward minus fs acting backward. Net force is equal to mass into acceleration, equation 1. Again, considering the rotatory motion, right? Because of rotatory means torque is responsible. What is the torque acting here? Because of the force into perpendicular distance. What are the forces will provide the torque here? Mg, torque about the axis of rotation, center of the body we will consider it. When you are taking this axis of rotation, this force also passing through the axis of rotations, no torque by this force. This component of the force also passing through the axis of rotation, therefore this also cannot contribute any torque. This mg sin theta also cannot contribute any torque. Normal force also cannot contribute any torque. One and only frictional force will provide the torque. Okay, this is the axis of rotation, right? So that only considering the rotatory motion, frictional force into r, which is called I alpha, I into alpha. Therefore, frictional force into, right, or take that side, I means m k square. Why? Because k is the radius of gyration, which is different for different shaped bodies. Alpha is a by r, again r is taking a by r square. Okay, substitute this f value here, therefore we will get mg sin theta minus m k square into a by r square. Take this one this side, therefore is equal to plus m a. If f is taking this side, becomes minus, becomes plus, therefore m cancel, g sin theta is equal to, take a common, 1 plus k square by r square. From this one we find a is equal to g sin theta by 1 plus k square by r square. This is the acceleration of a rolling body down the inclined plane. Okay, if body up the inclined plane mean frictional force will be acting in the same direction of the mg sin theta component. But when we know the acceleration, we should calculate the time taken or velocity or coefficient of friction. Okay, all this very easily we will find. Let in 2 minutes you just concentrate. Very easily we will calculate the First we will use from linear equation v square minus, let initial velocity of this body starting from rest, v square minus v square is equal to 2a into what is the distance it travels, L we taken initially 2a s. Therefore v square is equal to 2 into what is a, g sin theta by g sin theta by 1 plus k square by r square into L. Therefore, here we will change to g. What is sin theta? Sin theta is equal to h by L. H by L into L by 1 plus k square by r square. Finally, v is equal to LL cancel 2gh by 1 plus k square by r square over root. So this is the second value. Similarly, third value, if you want, what is that? Anyone? Frictional force or coefficient of friction or time taken. What is the time taken? T is equal to velocity of the translational velocity by translational acceleration. So from this one, translational velocity already we calculated 2gh by 1 plus k square by r square over root divided by g sin theta by 1 plus k square by r square. So this having root, this not having the root. Okay, after eliminating the sin theta, after cancellation, finally here we will get 2h by g into 1 plus k square by r square over root. This is the way, because this having the root, this having not root. That's why, okay, after simplification we will get this formula. Similarly, coefficient of friction also, that formula also here we know. So already I eliminated. Fs into r is equal to mk square by Fs is equal to mk square into a by r square. Mk square by r square into g sin theta by, okay, 1 plus k square by r square. But what is Fs? Fs is equal to mu n. Mu n means mu cos theta, mu mg cos theta. Therefore, on LHS and RHS side, after simplifying here, mg cancel, sin theta by cos theta, tan theta divided by LHS side only, cos theta already over, right? Therefore, only mu calculated, mu only remaining. Right side only, how much, what are there? K square by r square by 1 plus k square by r square. So this denominator is divided by k square by r square every term we will get here. In place of k square by r square by k square, right, plus 1, because this is divided by this term. That's it. So this is the coefficient of friction formula, tan theta by, okay, 1 plus not k square by r square, this is only different, r square by k square, that is very simply. So in this way, all the formulas we very easily derived, and according to the moment of inertia, then by substituting that we will get the, okay, answers. For a sphere 250 mr square, for a disc mr square by 2, for a hollow, okay, sphere 2/3 mr square, solid, okay, like this. For by substituting all these values we will get. Similarly, they are asking the questions, what is the time taken to roll down of these shapes? When you know this formula, by substituting very easily we can find, okay. Or sometimes what are the ratios are asking, similarly any, okay. By using this all formulas without solving, just by estimating, we will find the solutions for all this, okay. Thank you.